Are we live? Yes, we're live. So, welcome to another episode of Business Focus Live with me, John, where we talk about business related topics as well as news from here and around the world. If you're new to this channel, don't forget to subscribe and let's get started. Where's the intro? There. Okay, and we're back. So today we have a special session. So we'll be focusing on the topic on linear programming. Now, for those who are joining me here, so if you have any questions as to any part we'll be discussing throughout the session, feel free to leave your comments down below or leave your questions down below and I'll answer one by one. Okay, so as I mentioned, so for those who are joining here, hopefully you've already downloaded the exercise that I mentioned earlier. So we'll focus right away on how LP is utilized. So just to go on overview, so what is LP? LP is linear programming. It's a complex tool that is used to answer complicated problems. So to find the optimal solution or the best outcome. So there are many applications, has a wider variety. Obviously, complex problem need complex solution or methodology. In this case, LP can do that. In particular, using Excel solver to aid in our process. So normally you would solve this mathematically using manual computation, which could take a long, long time, and which is prone for making errors. So for our purposes today, we'll be focusing on using Excel spreadsheet. Now, in order to use Excel spreadsheet and use Excel solver, you need to create the mathematical model, the equation, so to speak. So understanding and identifying each of the objectives as well as the different constraints is critical. So no matter what type of problem, what industry you belong, you can address using LP. So let's take a look here in this particular problem. So let me switch to the screen. So here we have a sample problem here. Okay. Thanks for the background, Grace, for the feedback. Yeah, I missed using it from our previous session. Anyway, so let's take a look here in our problem here. So here we have a sample problem. So you're asked to formulate the objectives and constraint and create a spreadsheet model to find the optimal solution. So my question here is, can you tell me what's the objective here? So look at the given scenario here. For those who haven't read the problem, you can read it now. So I know it's a very wordy problem, but this is typically what you would encounter in real life. So based on given scenario, what's the main objective here? Oh, hello, Megan. Oh, can anyone tell me what the main objective here is? Now, obviously, there are two primary objectives, right, for any business: maximization or minimization. So which do you think is the more likely objective here? And it's crucial to identify the right objective. Otherwise, you might get the incorrect solution or you'll be going the wrong direction. So can anyone tell me what the objective here is? What is the objective? And then we'll go next to identify the different constraints. Different constraints. So you need to help me here so we can expedite the process as well as help you in better understanding what the problem here is. So let's read the problem here. Hopefully by the end you'll be able to identify the objectives already. Oops. Okay. So Industrial Designs has been awarded a contract to design a label for a new wine produced by Lakeview Winery. So the company estimates that 150 hours will be required to complete the project. The firm's three graphic designers available for assignment to these projects are Lisa, a senior designer and team leader, David, a senior designer as well, and Sarah, a junior designer. Because Lisa has worked on several projects for Lakeview Winery, management specified that Lisa must be assigned at least 40% of the total number of hours assigned to the two senior designers. To provide label designing experience for Sarah, the junior designer must be assigned at least 50% of the total project time. However, the number of hours assigned to Sarah must not exceed 25% of the total number of hours assigned to the two senior designers. Due to the other project commitments, typo, Lisa has a maximum of 50 hours available to work on this project. Hourly wages rate are $30 for Lisa, 25 for David, and 18 for Sarah. So based on that statement, what could be the objective here? So what's the typo? Commitment. Okay. This is key here before we move forward. Identifying the objective is crucial here. Minimization of cost. That is correct. Very good. So minimize. So let me zoom out a bit so we can type in our objectives and constraint. Then zoom in again. Okay. So minimization. Okay. And how do we define the variable? So we have to define the variables first before we move forward. So what are the decision variables here? So what should we represent? So we'll make it easier once we're doing the equation later on. So minimization, like you mentioned earlier. So what are we minimizing? Cost, right? So what are the involved costs here? So for the project, what's the cost here? What are different types of costs involved here based on the problem? Not only we limit our scope based on the scenario here, so we cannot venture far. Now, obviously, in this scenario, it doesn't mention anything about fixed cost or total cost or variable cost. It only mentions about the wages or our hourly wages for each of the designer. So how should we define the variables here? Any ideas? So all the answers are already laid out here. You just have to identify it one by one. So who'd like to try? Sam, Yana, Miguel, Megan. So what do you think are the decision variables? So what contributes to the cost of the company? That's the key here. So knowing what affects your cost is the hint there. So meaning the people involved in the project are the cost. Very good. So meaning Lisa, David, and Sarah. That's correct. So, you can use the names themselves as your variables, but, you want to shorten it, make it as simple as possible, and easier as well. Okay? So, L is equal for Lisa. Sorry. Okay? Then we have D for David. And then we have S for Sarah. Not Sarah Geronimo, right? Anyway, so that's our decision variable. So how do we define our objective now? So minimize what? What are we minimizing? Minimizing cost, right? So how do we minimize that? How do we translate that into an equation? So you have to put them together. Obviously, it's all in the problem already. You just have to integrate that. Oh. Anyone? So for the objective, as mentioned, minimize cost, right? Minimizing the hourly cost for the three different designers as mentioned. So for Lisa, it mentions it's $30 per hour, right? 30L plus, that's 25D for David, plus 18 for Sarah. Okay? So that's 30L plus 25D plus 18S. So that's our objective here, minimization of cost. So next now is we need to determine the different constraints. So this is the key part here. So the objective is easy enough, but the problem lies in the constraints. Let me try to enlarge it so we have enough space. There you go. So what's the first constraint? So my suggestion here is to go with one by one. Start from the top of the paragraph before you go to the next one, so you don't confuse one over the other. So what's the first constraint here? So that's right, Jonathan. So it's 30L plus 25D plus 18S. Very good. Oh, for those who get correct answers, so I'll be grading your your response here. So extra points for the people who get the right answer. Anyway, so that's 30L 25D plus 18S. Okay, now how about for the constraints? So what's our first constraint here? Can anyone tell me? So what's the first constraint? So the cost involves the people involved in the designing of the project. So they're the main culprit here, so to speak. So how do we determine the first constraint? So the company estimates that 150 hours, so hours, I mistype again. So 150 hours, where is it? There you go. 150 hours will be required to complete the project. So that's the first key part. So how will we translate that into an equation? So let's highlight the text. Okay. I forgot the T. Sorry. So the company estimates the hours will be required to complete the project. So how will we translate that into an equation? Okay, Yana is saying, so L, so Lisa plus David plus Sarah is less than equal to 150. Or if you notice, Jonathan is saying it's equal to 150. Which is it? Which is which? Look at the keyword here. The statement says the company estimates that 150 hours will be required to complete the project. Meaning, do we use all of the 150 hours or any portion of 150 hours? So we need to clarify that first. Now, obviously, many will be confused with that statement. So again, so that's Lisa plus David plus Sarah. Okay. So the question is, what's the inequality? And ours is 150. Am I right? So we'll call that total hours. Total time. Okay. Well, so you can change that. So which do you think is the most appropriate here? Is it equal to, or what do you mean you can go more? The question is, can you exceed 150? Obviously, the limitation is only up to 150. The question we're trying to find out is, do we use all of the 150 or only a portion, including 150? So you need to find the distinction here. But based on the statement, it says 150 hours will be required to complete the project. So will be required tells you what? A portion or the entire 150 hours allotted? I'll go on, sorry. So the key here is it's saying that you have to utilize all 150 hours. Okay, so we will use equals to. Okay? I hope that's clear to everyone, huh? I know it can be tricky. That's the whole point of this exercise. So that's the first one. Okay, now how about the second one? What is our next constraint? Let me see here. It mentions about Lisa. Okay, so where is it? Lisa. Yeah, there you go. Lisa, senior designer and team leader. No, not this one. Where's the part? Because Lisa, and that's the part I'm looking for. Because, where's because? Now I'm confused. There you go. Lisa has worked on several projects for Lakeview. Ayan. Management specified that Lisa must be assigned at least 40% of the total number of, so let's highlight that. Let's use green. Okay. Total time of something hours. So let's take a look here. So management specified that Lisa must be assigned at least 40% of the total hours assigned to the two senior designers. So how will we translate this one? So keyword here is, this pertains to Lisa's constraint. So what's on the left-hand side, what's the inequality, and what will be on the right-hand side? Or baliktad, or the other side. Left-hand side, right-hand side. I get confused there. So let's take a look here. So how would you formulate this? Let's see. Yeah, Lisa's workload. So what's on the left-hand side? What should be the left-hand side? Yana is saying is Lisa, that's correct. It has to be greater than equal. So that's right. So greater than equal because it says here at least 40%. So it has to be more than 40%. So that's right. So let me type that here. So Lisa, okay. So it has to be greater than equal. Where's that symbol? Okay. Okay. So greater than equal. The question now here is what's on the right-hand side? So how do we translate that? Let's see if everyone can get it. So how do we translate that? 40%. Very good. So Yana got this correctly. So 0.4, so that's 40%, right? It says here 40% of the combined two senior designers, meaning we're talking. Check. Can you guys hear me now? How about now? Okay. So what was the last part I said? None? Wala pa. I'm confused. So delayed. There's a delay talaga, so don't worry about it. So what was the last part I mentioned? Can you type it in? So the problem we're dealt with here is, okay, thank you. I don't know if there's a problem with the connection, but I have to reset it in a bit. But we don't have time. Alisa, yeah. Okay, so the second constraint. So what's on our right-hand side? So it says 40% should be allotted to the combined total of the two seniors. Now, who are the seniors here that we're talking about? Yeah, 40% of the two seniors combined. Who's the senior designer here? Is it Lisa, David, or Sarah? Now you got it correctly. Now that's better, Yana. So that's correct. So it's the combined total of David and Sarah. Okay, so let me try and type it in. So zero point 0.4 times David plus Sarah. Okay. So let's call it Lisa's requirement. 40% requirement. Okay. So let's go to the third one. pertaining to Sarah instead. So Sarah, the junior designer, must be assigned at least 15% of the total project time. Okay. Let's try Lisa. Sarah, the junior must be assigned. Oops. Ah, wala. White label. Where's Lisa? Where's Lisa? Ah, Sarah pala, sorry. Ah, here you go. So Sarah here must be assigned at least 15% of the total project time. And let's use a different font. Let's make it darker para it's easier to see. Okay, so how will we construct the third constraint here? So Sarah, the junior designer, must be assigned at least 15% of the total project time. So how will we formulate this one? So for Sarah, obviously it's S, at least 15%. Okay? So how will we formulate this one? So Sarah, okay, is greater than equal to, so what's on our right hand side? So what's on the right hand side? 15% of the total project time. So it should look similar in our previous constraint for number 2. Right? Instead of just focusing on the 2 senior, we're talking 15% of the total aggregate time of all the designers here. So what could it be? 15% of what? That's right. So you're missing another comp, 15% of the total time. So you have to add the total time of all the, yes, so that's right. Don't put 150 right away because that's the whole point of finding out what's the allocated, right? Whatever the time it is, if it's 150 or less. But technically it should be 150 based on the first constraint, right? But we're trying to label it now. So that's correct. So 15% times the total time for Lisa, David, and Sarah. Okay? Times the total aggregate time of Lisa, David, and Sarah. That's it. So let's label it minimum for Sarah. Sarah Jerome. Okay. So what's next here? Here we have another constraint for Sarah. Sarah must not exceed 25% of the total hours assigned to the 2 senior designers. When I think of senior citizen. Anyway, so let's go back up. Okay. However, the hours assigned to Sarah must not exceed 25%. Let's use a shade. 25% of the number of hours assigned to the 2 senior designers. Okay? So this is in continuation. So this is another constraint. Okay? So Sarah must not exceed the 25% allotment of the total hours combined between the 2 senior designers, meaning David and Sarah. So how should we formulate this one? So Sarah, greater than equal? Is it greater than equal? Think about it. Must not exceed. You cannot exceed 15% or whatever the percentage was the requirement. Can you exceed or you cannot exceed? Can you go over or you're not allowed to go over? Miguel says greater than. Yana is saying greater than also. Rafael saying greater than. Incomplete. Rafael, that's an incomplete answer. Less than. Is less than the same as less than equal? So be very careful. Yes, that's correct, Grace. So less than equal is the right one. Okay? Very good, Miguel. So it should be less than equal. Okay, so let's must not exceed. That's right. So you can reach up to 15% but cannot go over. So meaning 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15%. But not beyond that. Okay? I just mentioned that Megan is saying less than. No, it has to be less than equal. You can reach 15%, but you cannot go over. Okay, please keep that in mind. Huh? So again, so S is less than equal. It's a symbol for less than equal. Less than equal 0.25. Then the combine of Lisa plus David. That's it. So let's call it maximum for Sarah. Okay? So are you still with me? So we now have 1, 2, 3, 4. 4 constraints. Do we have any more constraints? Do we have any more constraints here? Let's take a look here. Do we have any more constraints? Any more? Are we done? This is key here. Huh? If you lack one of the constraints, it's incorrect. If you have too many constraints, it's incorrect as well. The answer of Yana is yes, no. That's not the right answer. Max hours ni Lisa. Yes. So how will we translate that? So we have one more constraint. So as mentioned here, Lisa has a maximum of 50 hours available to work on this project. That's correct. So Yana is correct in stating the last one. So where is it? Lisa has a maximum of 50 hours available to do his project. Okay, so let's use a different color. Let's try purple instead. Okay, so the last constraint is Lisa has 50 hours. So how would we translate that? So Lisa is on the left-hand side. Mian is correct. So there's a non-negativity. So we forgot that part also. So we'll include that in the last one. So for the fifth constraint, Ray is saying Lisa is less than equal to 50. Is that correct? So cannot exceed 50 hours. So that's right. So it can reach up to 50 hours but cannot go beyond. Very good. So Grace is correct. Raphael is correct also. Okay. So Lisa, I think of Lisa Simpson. Less than equal to 50 hours. Okay, let's use it maximum for Lisa. Okay. Are we done? Are we done? We're finished, right? Are we done? Yes. Grace is happy. I too am happy. Are we done? So can we now solve it manually? Who'd like to solve it manually? Who'd like to volunteer? I give extra credit if you can solve it using manual method, which I do not recommend. Oh, guys and gals. So is it complete? Have we enumerated all the objectives and constraints? Or are we still missing something? Take note that this is critical in actual application. It's a scientific process, so it's an exact science. So you cannot have more constraints, you cannot have less constraints. It has to be exact. Nothing more, nothing less. So is Kenneth volunteering? I see his name, oh. He was the first one to reply. Seb could be a guinea pig. No, a volunteer, my mistake. No. So is there missing constraint? I think Ken was mentioning earlier, we have to always remember the non-negativity. This is a given. Now, there are different variations of linear programming in terms of what's the final requirement in terms of finding a whole number in terms of your optimal solution. Is it possible to just specify it in terms of whole number primarily? So in reality, if you notice, in production, can you have a fraction of a unit? So in production, can you produce half a unit? Let's say the optimal solution stated that to maximize profit, you have to produce 1.5 units. So obviously, in reality, you cannot have a fraction of a unit. So you have to show, or you have to change the parameter. It has to be whole number. The question is, do you change it to 2 as a whole unit, or reduce it to 1 as a whole unit. Now, obviously, there are advantages and disadvantages in doing that. If you reduce the unit to 1 whole unit, it will reduce the optimization or the objective. If you increase it to 2 whole units, it violates the requirement, meaning it exceeds the constraint. So, but that's for another discussion. Wage rates can be a constraint. Yes, it depends, right? So it depends on the scenario. That's why you have to be careful and read the statement carefully. So your English comprehension will be highly tested. That's the whole point. Right? If you notice, there's no more tables, so you have to read the statement one by one. So you have to break it down like how I'm doing today. Okay? Yeah, sipag to si Kenneth. Okay, so anyway, don't worry. Don't worry, you don't have to be shy. I don't bite unless if I'm hungry. Anyway, so continuing. So the last part is the non-negativity. So just okay. It's greater than equal to 0. Okay, so non-negativity. Okay, so now it's complete. So what's our next step now? We did the hard part, one half of the battle actually. So the first part is creating the spreadsheet model, the mathematical equation or the linear programming model. This is the basics of any formulation. So whether you're doing this in class or in work, you have to create this one. Now obviously for some scenario you may have more, for some scenario you may have less. So you have to identify it for yourselves. Now what's the next part now? We now have the objectives and constraints. Here's the part, how do you translate it into spreadsheet so that you can use Excel solver to find the optimal solution. Create the parameter and model. The spreadsheet model, that's right. Very good. So how do we do that? That's a big question too. Okay, so parameter, let me type it here. Parameter. So what should be included in the parameter? Okay. So what do we include? Okay. So what do we include in the parameter here? You have parameter, you have multi. Okay. So those are the two components. So what do we input in the parameter? Would like to try? Let's take a look here. What should be included in the parameter based on our objectives and constraints? Any guesses? So this will be key so that later on when you're plugging in the constraints in solver, it's easier. It's just point and click. You're not trying to ascertain how do we do this, how do we go about, and you go back to the drawing board, which is a big no-no. So you have to create columns for Lisa, David, and Sarah. That's right. So let's do that. Here. There you go. So we'll create rows for Lisa, David, and Sarah. Lisa, David, and Sarah G. Okay. So what else? So what else is given? So take note. So the hint here is to know what you are supposed to input in your parameter. Look at the constraints. That's the key here. Now obviously the objective has to be included as well. What's the main objective here? The minimization of cost, right? So you have to plug it in. So what do we call that? The cost. The 30, 25, and 18. What's the column that we will label it? Let me change my chair. What should we call it? So you always start with the objective. That's the easiest part. Dead silent. The hourly wage. Very good, Yana. Well, Yana is ready for the exam, huh? Hourly wage. Okay? So the hourly wage for Lisa is 30. For David, it's 25. For Sarah, it's 18. Okay? Simple enough. It's the first part. How about the constraints? Let's take a look here. Look at the first constraint. So what are we supposed to include? So it's already laid out. You just have to translate that or put those constraints and objectives in the spreadsheet model. Once you've done that, it will be easier and it will make sense later. Okay? So what's the next part? So what's our first constraint? What could be the first constraint? Any ideas, guys? Yeah, it's in your first constraint. What's the first constraint again? You have to input all of those constraints. Otherwise, you'll have a difficult time solving it later. So I'll give everyone a helping hand. So the first constraint is the total time, right? So what's the given time? Obviously, it's the total time. So that should be included in your parameter. Okay, so total time, total available time, or available hours is the same, right? Total available time or hours, right? It's 150. That's it. That's the first one. Okay, how about the second constraint? Yeah, so that's why we call it the total time available. So I've indicated that. So that's the first constraint. That's right. That's right, Sam. So what's the second constraint? The requirement for Lisa. So what do we put under Lisa? So do we create a column for Lisa? What should we call it? As the name suggests in our label. What do you call it? So if you notice, it says 150, 40%. Yeah, but how would we label it? Always remember, the number has to be attached to a label, to a word. So you would know, you would understand what we're talking about. The 40% represents what? Use a descriptive word. That's the easiest way. Workload. What precedes the workload? Why 40%? Why not 50%? Why not 60%? How would we describe the workload of 40%, so to speak? Diba? Why 40? Why not 80, 100, and higher? Requirement type, yes, but why 40% in particular? Diba? How would you describe? Why not 10%? Why was it 40% or higher? Look at the statement. Visa's 40% requirement, right? How would we describe it? Max time. Very good, Yana. Wow. Mukhang ready na si Yana mag-exam, ha? So, maximum time allotted. O, max time. Pwede na yun. So, we'll use max time here. Okay? So, for Lisa, the maximum time is 0.4 or 40%. Okay? Now, how about the next one? Si Sarah G. Well, you're getting it quicker, so that's a good sign. So you're more than ready for the exam. Maybe we should have a pop quiz today, no? No, just kidding. Anyway, so for the second one, take a look here. So it pertains to Sarah in this case, right? So do we create another column? And what title of the column should we label it? So now we have hourly wage column. We have the max time. What's the opposite? It's, yeah, but what do we label it? What do we call it at the top, at the row? Max time. Opposite is, what's the opposite? Oh, we completely forgot. Yeah, max time for, is it max time for Sarah? We're talking of the third constraint so far, ha? Wala pa tayo sa fourth. The third constraint so far. Oh, don't jump ahead. We do it one by one. Minimum time. Very good. Very good. Thank you, Stephanie. Is that correct, Stephanie? We have the same initials. That's my middle initial, your surname. Are we related? Minimum, that's, oh, remember that, Seb, huh? Don't forget, huh? Anyway, so it's minimum time. Minimum time. Okay. So minimum time is for Sarah, 15%. Okay. And then how about for, what do you call this? For the fourth constraint, so maximum of Sarah. So do we simply put 0.25 here? Can I put 0.25 there? Revelation. Well, that's my middle initial for all intensive purposes. That's why it's easy to pinpoint if you're related to one another or not. But my surname, it's a common name enough, surname. But my middle initial, it's uncommon. Anyway, I was going back. The max time for Sarah. Please take a look. This where there might be confusion. Kasi we'll go back to it later on. Kasi if you notice, look at the minimum, maximum. Look at the preceding, what's inside the parentheses. Okay? Right? Is there a distinction between the second constraint and the third constraint? Take a look here. The leastest minimum requirement, right? What's inside the parentheses? What does the D plus S pertain to? For better viewing. Yeah, much closer. Okay, so again, just going back as I was saying. Look at the inside the parentheses. The T plus S pertains to the senior designer, right? And then the L plus D plus S pertains to the all designers here. So there's a distinction. So you cannot just really say you add this, you add that. So you have to create separate categories here. So the senior designers, right? So you have to input the maximum time allotted for senior designers. Okay, anyway. Oops. So how do we do that? So we put max time of seniors. Okay. Okay, so that's max seniors. I'll shorten it. Max seniors is 0.4. Okay. Then the next one is the minimum time for all. That's why if you notice, minimum time of all has to be specified. Minimum total. That's a better term. So minimum total is 15%. Okay. The question now, for the fourth constraint, do we include that in the max seniors minimum total, or do we create a different column altogether? So for this constraint, the maximum of Sarah, do we still put it under max seniors, or do we separate it? Put a different category? Let's see here. Seb, you said different? You said no. Senior designers is D and S. Is it David and Sarah, the senior designers? Oh, I noticed something incorrect already. Let's see if you can find it as well. Who are the senior designers here? Is it David, Sarah, Lisa? Who's the senior designer? Is it Lisa, Sarah, or David? Yes, go ahead, Grace. Yes, you noticed. Very good. Plus point for Grace for noticing. Sarah is not the senior designer. So I intentionally put Sarah there. It's supposed to be David and Lisa. Very good. Okay? So I have to change this one. Otherwise, when you do this in Excel Solver later, patay. That's a big mistake. You just wasted the entire session. Okay? So going back now, with regards to the requirement for the fourth constraint, do we include it also under max seniors or do we have to create a different column? So should we include it under the same column, maximum for seniors, or do we have to separate it? Take note. Look at the comparison. Compare this one and this one. So the question you ask yourself, are they the same? Should they belong in the same column? If the answer is yes, then they should belong in the same column. Separate. Okay. Anyone who says otherwise, or how would we separate them? Again, Grace, you notice, right, for the D and L, right, for 40% requirement, is it minimum or maximum? Kaya I think everyone got confused there. Is the second constraint? Yes, I know it's confusing. So the second constraint, take a look here. It says greater than equal, right? Is it minimum or maximum? I know it's confusing. That's the whole point. What do you mean yes? Is it maximum or minimum? You have to type it in so I can see the answer. Maximum. Look at the inequality. Is it minimum or can you exceed 40% or is it the 40% the starting point? Very good, Miguel. It's minimum. That's why the inequality is the key here. If it is greater than, minimum yon. If it's less than equal, that's the maximum. Yeah, at least. So minimum yon. That's right. Very good, Yana. Yeah, minimum. Very good. So we have to create separate columns for that one. So let me delete first. Let's start again from the second one para there's no confusion. Okay? So instead of writing maximum for seniors, has to be the minimum. That's complete opposite. Okay? Minimum requirement. You know? Minimum for seniors, that's 40% allotted for Lisa. Okay? At least 40% and above, not the other way around. Okay? For the third constraint, we call it total time. Okay? Total time for all designers. Sorry. Total time for, which constraint is this? This is particular for Sarah, right? Sarah G. So that's 15%. Okay, so that's the third one. So are we clear now on the second and third constraint? Okay, so are we clear on that one? So let's go now to the next one. So the fourth, let's go back. So the fourth pertains to the minimum or maximum requirement for the fourth constraint. Does this pertain to the minimum or maximum requirement? So this pertains to the, yes, that's right, Siem. That's right. Okay? Because if you notice, if you think about it, greater than equal, it has to be higher. Right? What grade would you prefer? Greater than equal to 0, greater than equal to 1, or less than equal to 1? Right? That's my point. Right? So greater than equal pertains to the minimum requirement. Kasi 1 is the passing score. Obviously, if you get a higher grade, that's better. Right? Then on the other hand, if you think about it, what's the highest grade possible? It's 4. Right? So the grade that you can get in school, in your academe, it cannot exceed greater than 4. So it has to be less than equal to 4. Right? Anyway, I know it sounds confusing, but it all makes sense once you try to digest it over time. Okay, but let's go back. So the focus here now is on the fourth constraint, right? So do we create a separate column for Sarah for the 25%? Or do we include it in the same column? So in this case, we have to create a separate column. Why? If you recall, in the second constraint, that's the minimum requirement. In this one, it's the maximum requirement. Okay? So maximum for seniors. Okay? Yeah, okay. Maximum for seniors. Okay? So for Sarah, so the maximum is 0.25. Okay. And finally, how about the last one? Do we need to create a column? Do we need to include this? Of course, we have to. See, that's the all of the constraints, right? So you can just type in the maximum allotted time or total time, okay, for Lisa. So you create another column for Lisa for less than equal to 50 hours. Should we create another column? Okay. So do we need to create another column? And what should we call it if that's the case? So we're now on the fifth constraint, talking of maximizing Lisa's time availability. So in this case, we call it max hours for Lisa, or max time. For Lisa is 50. Okay? So now we have all of our parameters. Okay? So question now, what should be included in our model or our Moodle? What are we looking for? What do we need to find out based on our objective? Who would like to try? Come on. This is the easy part now. Look at your decision variable. That's your hint, right? You're trying to find out to achieve the least cost by determining the allotted hours you're going to allot for each individual. So what should we be looking for or trying to find out in our model? I think there's at least two that I see, right? Cost for what? That's right. What are we trying to reduce the cost? What contributes to your cost? Yeah, what contributes to the cost? Do we know? Look at the objective constraint. It's all there. The answer is already laid out. We just have to replicate it in the spreadsheet. Yes. So you need to find the rate and the hours. So hours. Okay, let's use total hours. Okay. But how do we determine the total hours and the total cost? Okay. So we need to reverse engineer this. But look at the objective. That's the hint first, right? What do you need to fill up? What do you need to know? Total cost. Okay. So we need to find this. This one also. But we're missing something. Sorry, we're missing something else. Production time, production time from, production time from what? Time from, getting closer. You're on the right track. Wait lang ha, I might lose the mic. I'm trying to change the microphone for a while. Check. Let's see if they can still hear me. Use hours for each individual. That's right. Can you still hear me, guys? I changed the audio now. Can you still hear me now? Can you still hear my voice? Is there audio? Okay, thank you. Thank you, Anna. So we're trying to find the hours allotted for each individual. Okay? So that's the first thing. How do you know? It's based on the objective, right? That's why you need to find out how many hours you're going to allot for each person. Okay, so you have Lisa, David, and Sarah G. Okay, so you need to find this, right? Apart from that, what else do we need to determine? The total hours. Okay? So what do we do now? If you notice, you have to plug in formulas here. So what formula are supposed to plug in at which part and at which particular portion? Here's the key part now, which everyone will be doing in the exam. Assuming the model is laid out correctly, we'll see later on. So what formulas do we need? Technically, we only need one, right? But look at the model. What formulas do we need to input? Oh, anyone? What are we supposed to input here? So take note, when you're trying to put the formula, obviously there's one specific formula for solver, the sum product, right? So where do we put the formulation of the sum product here? And actually, there's an obvious one that you need to put another formula. It's an easier one, but it lends itself based on the model that we have here. So here we have to put the sum product, right? Sum product. And what are we supposed to highlight here? Now take note, it highlights you have to supposed to select at least 2 or more arrays. So if you select a number of cells on one array, it has to be the same number of cells selected on another array. So it works in tandems, right? If you select one, you select another, select one in another cell. If it's 2, it has to be 2 in another one. If it's 3 and more and so forth, right? So what are we supposed to select here based on the, yeah, sum, yeah, correct. So there are 2 formulas as mentioned, sum product and sum. Okay, so let's start with the sum product first. So in this case, we're going to sum product the allotted hours, right? See, to determine cost, meaning how many hours is allotted for each person, comma, and the hourly wage for each individual. And that's how you find out what the total cost is, right? For example, you allot 1 hours for each individual, you get a total cost of 55, right? That's how you know. Okay, now, as mentioned, there's another formula you need to include, the total hours. So you have to put in sum and add all the total hours. But is that it? Do we need to add something else? Why is it itemized? Is all the formula included, or are we missing something else? Here's the home stretch. We're almost there. Ay, wala yung spreadsheet. Sorry. So I've included the formula already. Sum. Then you have the sum product. So is it complete, or are we still lacking something? Have we solved all the formula? Have we input all the formulas needed? Or are we lacking something? Or we can go straight to Excel solver. Let's see if we can solve it. Okay, so let's see if it's complete. Huh? So let's go to data tab. Na data analysis. Sanay na ako. Solver. Okay. Ay, ba? Can you guys see the solver? Can you see it in the screen? Which part, Grace? The formula, as I mentioned, total cost, you have to input the sum product. Kailangan, let me go back. So that there are two main formulas mentioned. So for a solver, you have to use sum product. Then the other formula is the total hours. Why do you need to put a total? If you notice, in this particular constraint, you have to add all of it. Right? Otherwise, if you were just to simply select this one as a totality, it would not work. It would give you an error in solver's result. Okay? Now going back. So can you guys see the solver? So right now. So I've reset it so that we'll start from the beginning. Okay, so what do we put input in the set objective? What cell are we supposed to reference? The mouse is not cooperating. So what are we supposed to input in the cell reference? So let me try to move it and minimize it. It's occupying the entire screen. There you go. Okay. And then not there. Where can I put it? I think somewhere here. Okay. Dito na lang. Okay, so what do we set the objective here? The wage? No, not Rafael. What's the objective? Look at the objective in the left side. What are we minimizing here? What are we supposed to minimize? The total cost. Very good. So what should we be highlighting? Oh, CF, can you answer that part? So that's the objective. So that should be be selected. Which one? The total cost. Very good. So select the total cost, which has the formula of the sum product. That's how you know. So that's the first. So maximum, minimum. Obviously, it's minimum, right? And by changing what variable cells? So what has to change? What do we select as it relates to the objective of minimization of total cost? What should we select? What has to change? If you notice, based on our model, something has to change, right, to be able to determine the optimal solution. So what could it be? The minimum? Yeah, no. Try again. Hint, it's already highlighted, so it should be easy for everyone. Yes, the allotted hours. So you forgot to label it. So in this case, where is it? So that's it. So highlighting their name. Okay? So that's one. Now, what's the constraint? Oh, here's the tricky part. So if you did it correctly the first time around, then it should be easy peasy now. So let's start from our first constraint. So this is our first constraint. So let me put it above para we can double check. So what do we highlight on the left-hand side? Let's see if you remember the process. So Miguel is saying total hours. Why total hours? Why don't we just select yung Lisa's allotted hours, Sarah, and David? Why the total hours? As mentioned, the total is the same as the sum, adding of all allotted hours for each of the designers. So Miguel is correct here. So the left-hand side is the total hours. That's it. Very good. And then what's the inequality? So it's equal to, and what's the right hand side? The constraint. So now, obviously, I prefer you focus on the parameter. Actually, you could select this one, but for our purposes, we always focus on the parameter and model only. So we'll select the total available time, which is 150. So that's the first one. Once done, you go to the second one. So we move downward. Okay. So let's take a look here. So what's our left-hand side here? What are we supposed to select? Yes, it will have an error. That's right. Very good, sir. And I did that the first time I did the solver problem. Right? And I soon found out that you have to create a separate cell or row or column that pertains to the totality. Okay? Oh, for the second one, what's our left-hand side? So we select Lisa. Lisa Simpson. And then the inequality is greater than equal. Now, how do we do the right-hand side? The 40% and then the D plus L. Oh, it's not the same as the total hours. So, do we have all of it? Can we solve it? So, 0.4 times, do I select the David and Lisa's cell and call it a day? Or is there something missing? 154 parameter. Yeah, we did that in the first concept. We're talking of the second one now. Lisa, minimum requirement of 40% of the combined total of David and Lisa's allotted hours. Total again, if you notice, the total pertains to all three. But if you look at the second constraint, are we talking of all three designers? It's not the same, right? Oh. Total of what? It's a total of something. But it's not a totality of all three designers, right? What could that be? D plus L. David and, not Kulay, but David and Lisa. So total of what? You're on the right track, but you're just missing one component. Kasi if you notice, the total for the first constraint pertains to all three designers. But in the second one, it pertains to something else. It's not the same. So what do we call that? The total time of we have David, we have Lisa. What do we know about the David and Lisa? That they are, look at the parameter, look at the heading, it gives you hint. That's the whole point of creating the different columns earlier. Oh. Total of seniors. Okay? And if you notice, in your model, it doesn't specify that. Yes, very good, guys. Now you're getting the point. So once you're dealing with the spreadsheet now, you can see, there's something missing. Okay? So we have to cancel this because it's incomplete. Okay? So we have to create another total. Total for seniors. Okay? Total hours of seniors. So let me close this. So I'll create another one. Total hours of seniors. Our seniors. Okay, something like that. Okay? And we put a formula similar to the total hours. So in this case, we put the sum of Lisa and David. Now we can solve for the second constraint. Okay? So let me highlight. So we remember. Okay. Then let's go back to solver again. See if we can solve it this time. Okay. So we have the first constraint down. So let's add another one. So as mentioned, Lisa is greater than equal. Okay. So 40%, 0.4 times. So the total of the senior citizen, senior designers. Sorry, my mistake. Okay. So you select the sum. Okay. So that's it. Now you can do it in reverse. Whichever comes first does not matter. You'll get the same result. The next is we add the third constraint now. Okay. For this one is the minimum requirement for Sarah now. This is much easier. So Sarah is greater than equal to 15% times. So what do we select? It says L plus D plus S. Is that total hours or total senior hours? So which is applicable here? So DL is not the same as DLS or LDS. So what do we select here? The sum of the total or the sum of the seniors? Oh guys, are we still up? Oh, we're in the home stretch. We're almost done. So for this one, sorry, this one, yeah. Do we use this? Which total? That's the question here. Rafael, are we talking of the total hours for all designers? Or are we talking the total hours of the seniors? Seniors or all? That's a debate that we need to clarify. Sum of the total, so you're pertaining to total hours. So let's find out if it's correct. So let's select total hours. And that's correct actually. So Rafael got it correctly. It says L plus D plus S meaning all three. So this is the total hours. So we click add. Okay. Next is the fourth constraint. So Sarah G. So let's move this. So you select Sarah is less than equal. So it's already the same. Then 0.25 times. Oh, what do we multiply? Total hours or total senior hours? That's right, Rafael. So in the first one, it's all. How about this one, the fourth one, the fourth constraint? Are we talking of all again still, or are we talking of uh, the seniors? This is the key part. We're down to the last two. So if you notice, it's the same as the second one. So yes, so that's right, Seb. So you highlight the total hours for seniors. Okay. So that's 4. Okay. We have a fifth one. Yes, that's right. L and D. That's why it's so critical you label, what do you call this? Enumerate the constraints properly. You have to go one by one. Because if you misspoke or miswrote in the first place, then it won't make sense when you're trying to solve it later on. Right? That's why this is technically your cheat sheet. You're allowed to use this as your reference when you're trying to input this in your solver. Okay? So for the fifth one, let me move this lower. So it's the maximum allotted for Lisa. Okay? So obviously we highlight Lisa, less than equal, so it's already there. Then 50. So we have the max time here for 50. Then that's it. Okay? So are we done? So the last one is the non-negativity. Woohoo! So we're almost done. Okay? So for the non-negativity, so no need to click as, so click OK. So check the box. For the non-negativity, then simplex method, then solve. Then voila. So what does the answer tell us? So clicking is so easy, but going through the process is the critical part. Okay? So did it violate the constraint? That's the first thing you have to check. Right? So what's the maximum allotted hours? It's 150. So it did not violate the first constraint here. Okay? Now, the second constraint, it says that it should be at least 40%, okay, of the total time of these of the two seniors, meaning David and Lisa. So you double check. How do you know if it's 40%? What's the allotted time here? So it's 120. Is that more than 40% of 120? Yes, it is. Right? You can do the actual math. And then for the third one, is it 15% of the total allotted time for Sarah? Okay. So obviously 30 is, let's see, let's try to divide this. Yeah, it's 25%. Okay. So it's more than 15%. So it does not violate. So it meets the requirement. And then for the fourth one, the maximum requirement for Sarah, which is 25%, which we already did, 25% of the total time of the seniors. Okay? And for the fifth one, is it 50, more than 50%? 50 hours, sorry. For Lisa. Less than equal, my mistake. So it's less than. And then, is it non-negativity? Yes, it is. So it does meet all the constraints. So it did not violate, so it met all the constraints, so you've done it correctly. So the answer here is, this is the allotment time. So actually, the hours assigned. Sorry. Okay, the hours assigned for each individual, and here's the total cost involved. So it would cost them, so the objective is to minimize the cost of $3,780. Okay, and that's it. Okay, yeah, sa wakas. Yes. Okay. Oh, question so far. So this is the entirety of what you're expected to do come exam. Okay? Any questions? Oh, you're now allowed to ask the question. Yes. I say it jokingly, but it's for a purpose. It's a redundancy if you notice. Creating the objective and constraint will be your guide once you're doing your spreadsheet modeling later on. As you can see in our example here, it's vital. Without it, you're not sure if you're doing it correctly. You cannot do it by memory, right? Even I can make mistakes, so what more for everybody else, right? So you want to be careful and make sure that you minimize making a mistake, right? Four. There are four problems. It's always four, if you recall. Yes, four. Let me type it here. Four problems, right? I never deviate. Four problems. Okay? So preparation is key here. Now, obviously, I will not give you a very long problem that would eat up much time, but it's a substantial enough that you have to know the process, the in and out, so to speak. Okay. Or anything else? So I think that's about it. So, wow, we've consumed a lot of time in just one particular problem. Any other questions? So before we conclude our discussion here. So just to sum up, formulating the objective is so critical. So I would highly suggest you try to redo it at home and finish the other examples I've provided. Now, obviously, there are videos already attached to it, so you can just review if you've done it correctly and try to analyze what the problem is. Okay? Now, if you have questions, now's the time to ask. Okay? So next session we won't meet because there's no class, which is technically good news. Okay, so anything else? Anything you want to add before we conclude? On readings on messages? Parang nagugutom na ako. If nothing else, I think that's about it. Okay? So, thank you for watching. So, I'll see you again on the next iteration. Okay. Okay, thank you. So, thanks for watching. I'll see you again next time. Okay? I think I was mentioned something about leap. Am I correct? Am I correct that you have leap activity? So, does that mean there's no classes for the entire, for the college? Is that right? I wasn't sure. Okay, either way. So let me know if that changes. But, we'll move already our exam by Thursday. Okay, that's about it. Thank you. So if you have any question, leave your comments down below. As always, Thanks for watching. I'll see you in the next one. Take care. Bye-bye, everyone. Saan ba yung outro ko? Para may music naman before matapos. End stream.